Hello everyone. So today we are welcome you in your next session in the sequence series. So in sequence series, this is our second session. In first session, we are familiar with the theory portion and first question. Here we have the question. Find the sum two n terms. And n terms is nothing but 1 square is there, 3 square is there, 6 square is there, and similarly here we have 10 square and 15 square is there. Okay. So if I want to calculate the sum of this type of term, then first I have to calculate T of R. So what is T of R here? So if I want to calculate T of R here, then just move from here to here. Value of 1 is become 3. Then from here to here, then 6, then 4. So here we have the gap of 2, then 3, then 4. And similarly on, here we have the gap of 5. Okay. So if, the number which are appeared here is in some particular type of. So first, if I want to calculate the nth term, then I can write it in this way. See, here are the series 1, 3, 6, and 10, and 15 is there. So I considered somewhere we have T of n term in this series. Okay. So if T of n is there, then let's suppose sum of this series is S. Okay. So I can take one more series, same series here, and put this first number below the second number, and similar on, put the second number below the third number, and so on. Okay. So in such way, here we have n minus of 1, and then T of n is there. Okay. If I subtract these two equations, okay, because sum is same, then S minus S is equal to 0. Okay. From here I get 1, and then 2 is there, and then 3 is there. Okay. Then 4 is there. Okay. Then 5 is there. And from here to here, see, from here to here, we have n minus of 1 term, and one more term is there. It means up to Tn minus of T of n minus of 1. Here we have total n terms. Why n terms? Because from 2 to Tn minus 1, n minus terms is there. And here we have T of n. Okay. If I take this T of n to the left hand side, then T of n is equal to sum of AP. Okay. Where n term is there. So what is the sum of AP? That is nothing but n by 2 is there. 2 plus n minus of 1 into 1 is there because common difference is 1. So from here I can write n plus of 1. Okay. So from here the value of TR is R divided by 2 and R plus of 1. Okay. So if we have TR, then can I calculate sum of this TR? It's easy for us. Okay. So sum of n term is summation of T of R. And here we have summation of R square, and here we have summation of R divided by 2 is there. Okay. So what is the sum of this term? N plus of 1, and 2n plus of 1 is there. And here we have n plus of 1 and divided by 2 is here. Okay. So see, if I take the common n and n plus of 1, then here we have 2 times of n plus of 2 is there. Okay. So because 1 plus 1 is there, it means this term, if I take 2 common, then this term become n plus of 1. N plus of 1 is here divided by 2. It means from here n plus 1 whole square is there. Okay, so in this type of question, first we have to calculate T of R, and after that I am going to calculate summation. Okay, so let's see some more problems. See, if we have the sum in this way, 1 cube is there, then 1, and 1 cube is there, then 2 cube is there, and here we have 1 plus 3, and in this way 1 cube, then 2 cube, and 3 cube is there, and here we have 1 plus 3 plus of 5. Okay, is this clear? And I want to calculate the sum up to n terms. If I want to calculate the sum of n terms, first we have to calculate T of R. Okay, so see, in first term, here we have 1 cube. In second term, we have 2 terms, and 1 cube and 2 cube is there. And in third term, we have 3 terms. Okay, so here we have 3 terms, 1 cube, 2 cube, 3 cube. In the similar way, in rth term, we have R term, and in R term, 1 cube is there, 2 cube is there, similarly R cube is there, and in the denominator, we have 1, 3, 5, sum of odd number up to R term. Okay, sum of odd number up to R terms. So what is the sum of summation of R cube? It is n. If R cube is there, then I have to take sum in the form of R. So here we have R plus divided by 2, whole cube is there, sorry, whole square is there. And what is the sum of odd number? Sum of odd number is if up to R. Okay. See, here we have the sum of 1 and 3, which is 4. 4 is nothing but 2 square. If I take the sum of 3 numbers, then this will become 3 square. Okay. In similar way, if I take the sum up to R terms, then it will become R square. So from here, I can write R plus 1 by 2 whole square is there. So T of R become R square plus of 1 divided by 2 is here. So if I want to calculate S of n, then summation of R square is there, 2 times of summation of R is there, and summation of 1 is there, divided by 2 is here. Okay, so what is the summation of R square? This is nothing but n plus of 1 and 2n plus of 1. And if I take the summation of R, then this is n plus of 1. And what is the summation of 1 n times? This is n. Okay, so here we have n by 2 also. Here we have divided by 6, and whole divided by 2 is here. Is this clear? So now I can cancel this term, and if I take the common n of n from first 2 term, then here I get 2n plus of 1 plus of 6 is here, divided by 6, and this is 6 of n if I take the LCM, and here we have 12 is there. Okay, so from here, see, if I take n common from these two equations, then n plus 1 is remaining, and here we have 2n plus of 7 is there, and plus of 6. Okay, now divided by 12. Okay, so n is there, n plus of 1 is there, and from here 2n plus of 13 is there, divided by 12. So n square plus of n, and 2 of n plus of 13 by 12 is there. Okay, so this is the answer. Let's see another problem. Now I am going to check one more series. See, just find the pattern. What is the pattern? See, if I take 1 plus 1 divided by 1 plus 2 and 1 divided by 1 plus 2 plus 3 is here, and in similar way I want to find the sum up to n term. So is there any pattern in the denominator? You will find. So see, if in first term we have only nothing but 1, in second term we have 1 plus 2, in third term we have in the denominator 1 plus 2 plus 3. It means in rth term we have 1 plus 2 plus 3 up to r is there. Okay, so if r is there, it means if I take the sum, then this will be r plus 1 divided by 2. Okay, so from here I can write this term r plus of 1. So can I write this term by using the method of difference? So see, here we have two terms. Can if 1 is there, then I can write this one in term of r plus 1 and r. See, here we have. So from 2 is there, then r plus 1 is cancel out. Then here r is there, r will be cancel out. Then r plus 1 is there. Okay. So here we have t of r. So t of r is here. Then if I want to calculate the sum of n term, then summation of t of r. Okay. So if I take the summation, then first I have to put 1 here. Then put 1 here, then this term will be, this term I get, and then again if I take 2, then here we have 1 by 2 and 1 by 3 is here. In similar way, 1 by 3 minus 1 by 4, and if I put the value of r is n, then 2 times 1 by n minus 1 by n plus of 1 is here. Okay, so see, here this term will be cancelled out, this term will be cancelled out, up to this term everything will be cancelled out. That means 1 is remaining and n plus of 1 is remaining. Okay, so now it's clear to everyone. Okay, let's take one more example. See, if we have question s of s is equal to 1 square is there and 1 raised to the power 4 is there. In the similar way, here we have 2 and 1 plus 2 square and 2 raised to the power 4 is there. Similarly, we have 3 divided by 1 plus 3 square and 3 raised to the power 4 is there. So on up to n term, I have to calculate sum of this series. Okay, so for this question, one concept is there. If we have a term x to the power 4, x square plus 1, algebraic factor is there. So what is the factor of this term? I can write this term in this way, see. Okay, this is the factor of 1 plus x square plus x to the power 4. So if I want to write the rth term from here, then t of r is r divided by 1 plus r square and r to the power 4 is there. Okay, so can I break this term by using this concept? So if I break this term, then here we have r square minus of r plus of 1. And one more term is here, r square plus of r plus of 1 is here. Okay, so see, here we have in the denominator, we have two terms. So can I write a numerator in term of denominator? See, if I subtract these two terms, then from here, r square plus of r plus 1 is here. And one more term is here, if I subtract this term. So what I get in the numerator? So in the numerator, you will find 2r. Okay, but here I see that here only r is there, so I have to multiply this term with r and also divide with, sorry, multiply with 2 and divide with 2. So in the denominator, r square r plus 1 is there, and one more term is there, r square minus of r plus 1 is there. Okay, so just see here this term and this term. If I cancel this term, then in the denominator I get r square minus of r plus of 1, and here we have r square plus of r plus 1. Okay, now I am going to use the method of difference here. So see, if t of r is this term, then t of 1 is 1 by 2. Just put 1 here, then I get 1. 1 by 3 is here. Okay, if I put t of 2, then 1 by 2, and here we have 1 by 3 minus 1 by 5. Okay, if I put 2, 2, 4 plus 2, 6 plus 1, 7 is there. So here I get 7. And here I get 4 minus 2, which is 2 plus 1, 3. 3 is there. Similarly, if I take 3, then 9 minus 3, 6 plus 1, 7 is there. Okay, so now from here I get similar term. And if I take 3, 9 plus 3, 6, it means here 10 is there. In the similar way, if I put n, then here we have 1 divided by n square minus of n plus of 1. And here we have n square plus of n plus of 1. Okay, so see, what is the summation? Summation is nothing but sum of t of r term. Okay, so if we add all these terms t1, t2, t3 up to tn, then here we get summation of t of r. And see, from here, can I cancel these two terms? Similarly, if I add these whole terms, then this term will be cancelled out up to 1 by n square minus n plus 1. All terms will be cancelled out. Only two terms will be remaining. So from here, one term is 1 and another term is n square plus of n plus of 1 is there. So I write this term n square plus of n divided by n square plus of n plus of 1 multiply 1 by 2. Okay. See, if I want to calculate sum up to infinity, then this n will be infinity. Then it means this term will be 0. So what is the summation of up to infinity term? 1 by 2 is there. Okay. Anyone has doubt? Okay. So I think this question will be clear to all of you. If you have any doubts in this question, then you can just suggest me in the chat box. Okay. So I will share you my email ID and some WhatsApp group where you can ask the question directly to me. Okay. So let's see one more question, and now I am going to solve some question from the method of difference. So write down the question. Find the n term, nth term. Sorry, find the nth term and the sum of given series. Okay. So here we have first series. Let's suppose we have 1 plus of 9 plus of 24 and the similar way 46 plus 75. 46 plus of 75 is there. Okay. So I want to up to n terms. First I want to calculate nth term and then summation. Okay. So let's suppose this summation is 1 plus 9 plus of 24 plus of 46 up to 75. Then somewhere we have term t of n. Okay, so t of n is there. So if I subtract s from this s and I write this first term under the second term, and similar way, if I write in this way, Then here we have just below the Tn, T of n minus 1 is there, and here we have T of n. Okay, so if I subtract these two equations, then S minus of S is 0, 1 is there, 9 minus 1 is 8 is there, and if I subtract 24, 9 from 24, see, I think 15 is there. Is this clear to everyone? And similarly, we have 22 is there. Okay, and here we have T of n minus of T of n minus of 1, and this term will be negative, and I take this term to the opposite side. Okay, so T of n is there, so I write T of n here, and see 1 plus of 8 plus of 15 up plus 22, and this term are in AP. And if I take the term from here to up to Tn minus 1, then n minus 1 term is there. But luckily, this one is also included in this series, and it make this sequence in AP. Okay, so can I write T of n is n by 2, 2a plus n minus of 1 into d, and in place of d we have 7. So n by 2 is there, and 7 of n is there, and minus 7 plus of 2, it means 5 is there. Okay, so here we have T of n. So if I know T of n, then I can easily calculate summation. So here we have the summation, and summation is 7 by 2 summation of, you can write, if I write T of r, then r square is there, and here we have 5 by 2, and r is there. Okay, so what is the summation of r square? N plus of 1, 2n plus of 1 divided by 6, and 5 by 2 is here. And what is the summation of n plus of 1 divided by 2? Okay, so this is the answer of this question. If now I'm leaving this term to use, so simplify this expression. Next question is, see, 3 is there, 6 is there, 11 is there, and again we have 18 is there, and so on. So this is the sum. So just take T of n somewhere, and just again write 3, 6, and again 11 is there. So here we have T of n minus of 1, and T of n is there. Okay, so if you have any question which you will find that this term are not in AP, GP, and HP, then the question will be solved by method of difference. Okay, so if I subtract these two terms, then 0 will be there, 3 is there, and 6 minus 3 is 3. And if I subtract this term, then 5 will be there, again 7 will be there, and from here you will find that up to Tn minus of Tn minus 1 series will be formed, and here we have minus of Tn. So if I take Tn here, then 3 plus of this term is the summation of n minus 1 term, then n minus 2, 6 is there, n minus of 2 is there, and what is the difference of this AP? 2 is there. Okay, so from here 3 plus n minus of 1 by 2, and 2 of n, and 2 plus 2 is there. So I write this term 3 plus n plus 1, n minus 1. It means n square minus of 1 is there. So I write this term n square plus of 2 is here. Okay, is this clear? So now I have T of n, and if T of n is there, then I can write T of r also from here. So r square is 2. What I did here, I just replace n with r. Okay, so if I want to calculate the sum, then summation of T of r is summation of r square, and summation of 2 is there. Okay. So what is the summation of r square? So n plus of 1 and 2 of n plus of 1 divided by 6 is here. And if I take the summation of 2 n times, then this will become 2 times of n. Okay. Now it's clear to everyone. So let's see one more example. Now I'm taking one example from common sense. Okay, now you can tell the sum of this expression by observing. See, 3 is there, then here we have 8, then again we have 15 is there. Okay, so again we have 15 is there, 15 is there, then we have 24 and 35 is there, and so on. And I have to calculate the sum up to n term. See, if you see this expression, then you will find this 3 number is just 1 less than 4. And similarly, this number is just 1 less than 9. And in similar way, this number is just 1 less than 16. Okay, and 9, 16 will be a perfect square. So can I write this number in this way? 2 square plus minus 1. And in similar way, 3 square minus 1 is here, and 4 square minus 1 is here, and 5 square minus 1 is here. Okay, so in similar way, T of R is, see, in first term we have 2. It means in rth term we have R plus 1, square is there, minus 1 is there. So I can write this term A plus B minus B, then from there, see, I write in this way. So r square and 2 of r is there. So if I take the summation of T of r, then summation of T of r is summation of r square plus 2 times of summation of r. Okay, and you already know about the sum of this term, summation of r, n plus 1, and 2n plus of 1 divided by 6 is here. And from here I can write, see, n is there, n plus of 1 divided by 2 is there. Okay. Now I'm going to take one more good example from AGP. See, here we have one summation, and this summation is equal to 1 plus 1 plus 1 by 3. Then again we have 1 plus 1 by 3 plus 1 by 3 square is here. And in this way, we have summation. Okay, let's take one more term here. 1 by 3, 1 by 3 square, and 1 by 3 cube is there. Okay, let's take 3 cube, this term. So up to n terms, I have to calculate the summation. Okay, so now same method is there. Take s here and subtract this 1 from this term, and subtract 1 plus 3 and write this 3 term just below the third term. And in the similar way, write this third term just below the. Okay, is this clear? Now what should I do? Just multiply this s with 1 by 3. Then this term will be 1 by 3. And this term will be in this way. Here we have 3 square, and then 3 square is there, and 3 cube is there. Okay, now it's clear to everyone. And just subtract these two terms. Okay, so if I want to calculate the sum up to T of n term, then take T of n here. Here we have T n minus 1, and again here we have T of n. So in plus sign. So if I subtract these two terms, then 2 by 3, s is there, 1 is there, 1 is there, and 1 by 3 and t square is cancelled, then 1 is there. Is this clear? Okay, here we have term 1 is there, and if I multiply this term, then 1 by 3 will be cancelled out. Here 1 by 3 and 1 by 3 square will be cancelled out. Here we have three terms, then this full term will be cancelled out. It means I get 1, 1, 1. Again, here we have Tn minus of Tn minus of 1, and then minus of Tn. So I should not calculate T of and minus of 1. So I need not to be write this term. Okay, so if I want to calculate T of n, so just find Tn is there. What is Tn? See, this is also in GP. So Tn term is nothing but 1 plus 1 by 3, 1 by 3 square, 1 by 3 cube is there. Okay. So this is the fourth term. Here we have four terms. It means in another term we have n terms. So last term will be, if I subtract from here up to here, so see this term will be nothing but GP. It's a GP. First term is A, and 1 minus 1 by 3 n is there, and here we have 1 minus 1 by 3. Okay. So 2 by 3 of S is equal to, from 1 to this term, n is there, and here we have 1 minus 1 by 3 n is there, and 2 by 3, it means 2 by 3 is nothing but 3 by 2 is there. Okay, so from here, can I write this as is 3 by 2 n minus 3 by 2 whole square, it means 9 by 4 is here, and 1 minus 1 by 3 raised to the power n is there. Okay. So this is the answer. Okay, just cancel out the term. In this type of question, just to find the common, see here, by common sense, I can find, if I multiply with 1 by 3, then this term will be cancelled out. Okay. Okay, now we are going to take some more examples in this type of question. See, one question from GP, okay, and method of difference, if the difference will be in GP. Let's take S is equal to 5 plus 7, and 13 is there, and again we have 31, again we have 85, and this is the sequence. So if I subtract S from here, then 7 is there, 13 is there, and 31 is there. And in the similar way, see, if we have Tn, here we have Tn minus 1, and T of n is there. Okay, if I subtract these two terms, 0 is there, then 5 is there, 2 is there, and if I subtract these two terms, see, 4, and then again we have 8, 13 plus, I think here we have 20, 31 is there. Okay. So 5 is there, and here we have 2. Then again from here, if I add 3, 3, 6 is here. Sorry, 6 is here. So here we have 6, and from here, can I write 9? 13 plus 9. I think 9 is not there. If I add 7, then 20 is there, and 20 and 11. 18 is there. Okay. So here we have 18. And in the similar way, we have the terms. And here we have T of n minus of T n minus 1. And minus of Tn is there. Okay. So can I write this Tn in this term? See, if I take 2 common from the remaining term, then you will find that here we have 1. Then again 3 is there. And 9 is nothing but 3 square is there. So up to n minus 1 term, you will see this is this term are in GP. So can I find the sum of GP for n minus 1 terms? So here we have the first term, and 3 raised to the power n minus 1 is there, minus 1, and 3 minus 1 is there. Okay. So cancel this term with this term. Then from here, 5 plus 3n minus of 1 minus 1 is there. That means 4 plus 3n minus 1 is the t of n. Okay, so now I have calculate t of n. So from this t of n, if I want to calculate sum, then summation of 4 is there and summation of 3 of r minus 1 is there. So in place of nth term, I write rth term. Okay. So if I add 4 n times, then 4 of n is there. And this term will be in GP. So first, what will be the first term? If I put r equal to 1, then 1 is there. So I write the sum of GP is 1, 3 raised to the power n minus 1 by 3 minus of 1. Okay. So answer will be 4n plus 3 raised to the power n minus 1 by 2 is 0. So this will be your answer. Okay, I think we are moving forward to solve some level of problems. So these are the usual problem which we will ask in AODs, sorry, in method of difference. So we have some problems which are good and need some special skills to solve this type of question. Okay, so let's see. So here we have one question. If uh, 1 second. So let's see what will be the question. Here we have some terms which are in AP, and it is given in the question that, see, these terms are in AP and A of I is not equal to odd multiple of pi by 2. Why? Because this term will be 1 by cos and cos will be 0 at odd multiple of pi by 2. It means 1 by cos of pi by 2 is, if we have 0 in the denominator, then this term will be undefined. So to avoid, to make this term undefined, I take A of I is not equal to 2k minus of 1 pi by 2 for all I. Okay, is this clear? So here we have undefined. Okay. So now if you have any equations in the series form, then method of difference will be applied if the sequence R is not in AP, GP, and HP. Okay, so let's see what should I do. Here, my motive is to convert this term into difference of two consecutive terms. Okay, so for from here, can I write this term in cos of A1 and cos of A2? Okay, and I want to make this a term into difference. So if I take sine of A2 minus A1, okay, because cos term is there, so cos of A1 and cos of A2 is there. Okay, so if I take this a term, then let's see, here we have sine of A2, cos of A1, again we have sine of A1 and cos of A2 is there. And just divide this whole term with cos of A1 and cos of A2. Okay. So if I divide this term with cos of A1, then cos A1 will be cancelled out. Here we get tan of A2. And if I cancel cos of A2 term, then here we get tan of A1. Okay. So see, I write this term in the difference of two consecutive terms. If these terms are in AP, then can I write D, which is common difference, is equal to A2 minus of A1, A3 minus of A2, and in similar way, A of N minus of AN minus 1. Is this correct? Okay. So see, this term, I multiply this term with sine of A2 minus A1. This is A2 minus A1 is the difference, and this difference is equal to D, and which is constant for all this term. If I take the difference between two consecutive terms, it means if I multiply this whole expression with sine of D and divided by sine of D, then I can write this term in this way. See, if I take here, if I take sine of, in place of sine of D, A2 minus A1, so this term will be converted into tan of A2 minus of tan of A1. In the similar way, if I take here, in place of D, if I take A3 minus A2, then this term will be converted into A3 minus of tan of A2, and so on. And finally, we get tan of A of n minus of tan of A n minus 1. See, can I cancel this term? Here, this term will be cancelled out. So from here, I get, in first, last term is there, and in second, first term is there. So if I cancel all this term, then this term will be remaining. And from here, so I get sine of D and tan of A of n minus tan of A1 is there. Okay. Also, I can write this term in this way. See, can I write tan in term of sine? So this term will be there, and cos of an will be there, and sine of a1, and here we have cos of a of n. Okay. So I write this term sine of an, cos of an, a1 is there, and here we have sine of a1 and cos of an is there, and again we have two terms in cos of a1 and cos of an. One more term is there, sine of d. Okay, if I subtract this, see, here we have the formula in the numerator, sine a cos b minus cos a sine b. So I can write this term in sine of a of n minus of a of 1. Okay, and from here, this is converted into sec of 1. Sec, if I want to write answer in sec, the sine of d. And here we have this term I can write in this way, sine of n minus of 1 into d, and here we have sine of d and sec of e1 and sec of a of n. Series. So this is our second lecture in summation of series. In our third lecture in summation of series, we are going to solve the advanced method. Okay. That will be at the good level. Okay. This level lecture, if anybody want to prepare up to mains paper, then you should watch lecture 1, which is theory 1, and this lecture, which is numerical part. Thank you so much, and I will see you later in next lecture.